Hey everyone, welcome back. Today is day 5 of my 30-day FAANG grind, and I'm solving 6 to 10 LeetCode problems daily, breaking each down on video and sharing with all of you on YouTube. I'm Divya, by the way. I've interned at Massachusetts Institute of Technology, where my area of focus was in statistics and machine learning. Right now, I'm at top 0.3% on LeetCode, and like most of you, I enjoy LeetCoding. Over the last few days, we have tackled problems based on sliding window to pointers, prefix, and suffix based problems, and also problems based on strings. Today, we will be dealing with stacks. We'll solve problems based on monotonic stacks, mixed greater or smaller elements, and problems of such nature. These problems will teach us structure, flow, and how to handle state across elements, which is key in interviews. Before I begin, if this video helps you, please drop a like and consider subscribing. You can also share my videos with your friends. And yeah, let us begin. So today we will be tackling LeetCode 155 minimum stack. It is more of a design problem, and we have to design a stack that should have these features. Features like we should be able to push, we should be able to pop, and we should be able to use this top method online material, which will help us to get the top element of the stack. And we should also have the method number 15, line number 15, get min method, which should allow us to access the minimum element across the stack in a constant time. Now, if you look at this method, get min, which is asking us to fetch the minimum element across the stack in a constant time, this method indeed sounds amazing, right? So we'll see how we can come up with a method in a constant time for this specific case. Yeah, and these are the examples that we have been given and the constraints. Let us go to the dashboard and we'll try to investigate and spend much time on get-me method because that is the only method that requires a little bit of thinking. Apart from that, all those other methods are just something which is very easy. Okay, I am on the dashboard. Till now, this is how we used to think about a stack, right? At every state, we could either push an element to the stack and then pop an element from top of the stack. Every single element that you're looking at is a singleton element, means they are just an element of one nature. And every array memory here and the memory in this stack, they are just referring to a single element, okay? In a much more general sense, this is how we were perceived or how we are generally perceived into thinking of an element into the stack as element 1, element 2, element 3, element 4, and so on and so forth. And what do you notice over there? We notice that these elements are just by themselves. These are just alone and they do not have any other composite element to itself. It is not heterogeneous. It is just single element, right? At any memory level, correct? Now, if you look at how we will be dealing with this problem today, we will not just have a single element at any level. Instead, we'll have two different elements. Those will be the current element, which is the E1 or E2 or in general EI, and we will also have current minimum till that point. So in the array memory, in the stack memory at any level, we'll have a structure of this nature, element I and current minimum. Okay, and this current minimum will be the minimum till element I, including element I. Okay, so this is how we will frame our structure or how we modify the structure in the stack. By the way, when I say structure, those coming from C++ or C background, do not think of that structure as a keyword in your language. Okay, I just want to take a few seconds more just to discuss something else. See, I could go on and discuss how the memories are allocated to every single element in a single level. Okay, but I think we should not digress a lot, and maybe I will just keep it as something that we can address far later ahead in our course. Okay, so let us go to the LeetCode dashboard and we'll try to code this up. And this is a very easy problem, so I don't think we require much explanation on dashboard. So instead, I will just let my keyword do the talking. Okay. I'm at the task LeetCode, and let me first start off with initializing a stack by simple stack. I'm coding in Python, and its structure will be value and minimum value till that point. Okay. Now we have to write the push method. Push method, we have two cases. Two cases will be, what if the stack already has some value? What if the stack already has some value? And the second case will be, what if the stack is empty? Or what if the stack has not encountered any value yet? So let us deal with the second case. If the stack is empty, so in that case, we can simply append this value in the parameter to the stack, self.stack.append the given value, and this value, which is the first value in the stack, will be the minimum value till that point. Okay. But what if our stack has some value? In that case, what I'll do, I'll fetch off the minimum value from the top of the stack. I'm accessing the top of the stack by -1 and then indexing 1, which will give me minimum value, right? And then I will store that minimum value in the variable minimum value. And then on the stack, self.stack.append, I will push it value and the minimum value till that point. So let us come to this pop thing. We just have to pop, right? So self.stack.pop. It will remove the top of the element of the stack. Okay, that is what we want. And how about if we want to pick the top value on the stack? In that case, I will in that case, I will do self.stack.pop. Oh, we just have to we just have to fetch the value, right? So it will be self.stack, access the top element using 1, and index it using 0 to get the top element. And in order to fetch the minimum, it will be pretty much similar to the top, just the index will change. Self.stack, fetch the top, then the minimum one using index 1. Let me submit this, and I hope and I think it should run just fine. Uh-oh. Okay. So it gave me an error. Let me see the error. It says that a stack is not defined. Why? Because it should be self.stack, not stack. Just a Python thing over there. And I think it should just work fine. No, it do not. So where is the issue that we're fetching? Mm, okay, we are fetching the minimum value at line number 8, and then we're appending the value rule, and then I'm popping the stack value. This should not happen to case 0, 1, 2, 3, 4, 1, 2, 3, 4. We are getting an error. Let me just paste my code, and I think this will work fine. Okay, I think there was just a typo in that earlier code. So I've just copied and pasted my last code. Yeah, and as you can see, this works just fine. Okay, I think I messed up a bit in the earlier code, the typing piece. Okay, but anyway, so yeah, that was all there was to this problem. I hope you understood it. The time complexity is order of n, uh, because and the space complexity is order of n as well. The time complexity depends for each of these methods. So yeah, in general, I'm summing it up to the linear case. So yeah, that was all there was to this problem.